and thank you for coming to my session when you think there is no time for learning or coding. My name is Eleftheria. I am a front-end developer and content creator and also a UX master student. You can find me on my social media. I'm quite active on Twitter and on Instagram too, but also feel free to send me an email if you have any question or anything, or even you can find me on YouTube under the name Eleftheria Batsu. All right, now in this session, we will talk about my coding journey, how I started, how I got into tech, what helped me, what didn't help me, and some tips which I believe that they can also help you. The second part is how to form habits, why to form habits, how they can help you, and why it's important to form these habits. And last but not least, on the third part, we will talk about how to deal with frustration, how to deal with stress, and how to achieve all of your goals. Are you ready? Let's do this. Okay, so let's start, as I said, with my coding journey and how I became a front-end developer. Well, I graduated from an informatics and telecommunications of engineering kind of university. It's a polytechnical university, which is like 5 years. And I did a lot of maths, I did a lot of physics, I did a lot of electronics, but not so much of coding. And I wanted to be a front end developer. I knew that, but I didn't have the skills. So I I said, why not doing like an internship? And I did that internship. I am originally from Greece and I got the opportunity to do it abroad, specifically in Amsterdam. So I went in Amsterdam and I started doing this internship. It was exactly what I wanted. It was on front end development. And when I was almost like done with it, I knew that I wanted to find like a real job as a front end developer. And I started looking at the job descriptions. And this is the hard part. I realized that I didn't have the skills that the jobs were asking for. I I didn't know good enough like JavaScript, I didn't know any framework, I didn't know how to use Git and GitHub. I didn't know any of this stuff. My level of coding was a very very basic one. I was a little stressed because my internship was about to end and I didn't know what to do. Back then, and still until now, every morning, my morning routine includes reading tech articles. So one day, while I was in my living room in a rainy day in Amsterdam, I read an article in Medium written by Alexander Calway, and this title had in the title it was something like 100 days of code and the benefits of it. I said, okay, let's read that article. And now, in that article, the creator of the challenge, 100 Days of Code, he was explaining why 100 Days of Code can help you achieve your goals, be better at coding, and land a job. And guess what? That was exactly what I wanted to do. I wanted to improve my skills and I wanted to find a job. So I said, heck yeah, let's do this. 100 Days of Code, let's do this. Now, in the challenge, there were some rules. The first rule was that I would code for 1 hour every day for 100 days. And that would actually help me to improve coding and improve my skills in general. The second rule was to upload my code on Git or another open source activity. So at first, I didn't know anything about Git or GitHub or GitLab or stuff like that, like really anything. So it was like also a good opportunity to learn about that. And the second important thing here was that I eventually started building a portfolio. I were hosting my project somewhere. It was in a public places and people could see those projects. So that was like really beneficial. The third part of the challenge was to go on Twitter every day again and use the hashtag 100 days of code and like share my progress there. And also, if I wanted, I could give feedback to other people. I could encourage other people to take part in the challenge. And of course, I was also like asking for feedback for my projects. Again, that was a brilliant thing because I was at first quite afraid to go on Twitter and start like talking about my progress, especially thinking that I was like a total beginner, a total newbie, which I didn't know a lot of things. So it was a little bit hard at first, but eventually I think that it really helped me a lot. And it also helped me to connect with other people because it's not only having those perfect skills, but it's also connecting with people. Now, a lot of people asked me back then and still ask me now, what do you code? And like a lot of people say that they also want to code, but they don't know what to code. For me, an easy answer. I can give you like an easy answer because there are so many things that you can code. There are so many things that you can build. Just let your imagination play, and you will find really, really amazing stuff out there. Also some sources to learn because again a lot of people didn't know from where to start. So there are online educational platforms like Udemy, Udacity, Coursera, like so many things, and you can find a lot of courses for free too. And then of course it's YouTube. I love YouTube. I watch daily YouTube. There are so many courses again there. You can find like courses for beginners, for experts, and really anything. And then there are online communities. And what I mean by that is Stack Overflow, hello, but also like Discord servers and other channels like Slack channels that you can go into them and find people that are equally excited as you are. And there are some other coding challenges. Like so far, I have mentioned only 100 days of code. Later, I will mention other challenges as well. But there are other coding challenges that they give you each day a theme or a small project to build. Like they send you an email and they say, like, build that or that or that. Or they also share some links about some good articles or some other online sources. And last but not least, there are obviously magazines and books. I like to read a lot of tech articles, as I already said, but also books are amazing because you can go in depth about a subject. As for inspiration, again, like read blogs, browse forums, check or like follow your favorite people on social media, check their GitHub, check their portfolios, see what they are up to, and also go to meetups and attend to conferences. Like right now you cannot do that physically, but of course you can do that online, which is actually kind of better because you're at home and you can watch other people talking. And since you are here, I'm pretty sure that you actually do that last step. Okay, now let's go back to me and I will share a little bit of what I wanted to learn in order to be a front end developer. And please remember that it was like my very, very first steps, and I didn't have like any external guidance on what to do. So my first goal, and as I was saying, the job descriptions was to be a rock star on HTML, CSS, and JavaScript. And then, of course, learn how to use Git and GitHub because, again, I was seeing that everyone was asking for it. I wanted to stop being afraid of the console and the developer tools in general because I could see again like other developers at my internship where I was internshipping, where I could see other developers on YouTube that they had this black screen with the console or they had opened the developer tools. But before that, I had no idea what were these things were and how I could use them. And also, I wanted to learn something extra, like learning a framework. I started with angular.js. Yes, I said angular.js. So now I know that it wasn't a good option. And for those of you who don't know that, learning angular.js was not a good option because now angular.js is going to be deprecated. So that was not a good option. But I still learned it. And also, I learned a data visualization library called D3GS. That was actually pretty helpful because that's how I also landed my first developer's job, which was actually remotely. and it was perfect for me. So, yep. Now, what did I build during those times, like those 100 days? As I said, my main goal was to learn HTML and CSS, so let's start from that. I took part in another challenge called Daily CSS Images, and in this challenge for 50 days, I was coding only with CSS, and every day I was getting a theme into my email, and that theme was like code a cat, code a sandwich, code Superman, and I was trying to do all those things only with CSS. So what you're seeing right now is like the result of it. My next step was to learn JavaScript, and I started working with FreeCodeCamp. For those of you who don't know, FreeCodeCamp is a free, amazing source to learn how to code, and the JavaScript part is amazing. So I started doing some games like this one, the tic-tac-toe game, another one, the Simon Says game, and then I also starting to playing a little bit more with angular.js. The fun part is that sometimes I still say that I know angular.js, and if people ask me, you mean Angular, Angular 2, 8? No, AngularJS. Are you sure you know AngularJS? I mean, sometimes I say I know AngularJS and people don't even believe me. But do keep in mind that this was like 3, 4 years ago. Okay, and then I continue with the data visualization library called D3GS, which, as I mentioned, it was actually pretty good because it led me to my first job. And oh, and before that, how it led me to my first job was that I started creating YouTube videos, and in these YouTube videos, I was coding, and at that time, I was coding with D3. I was like creating some game. I was creating stuff like this that you're seeing right now, and someone approached and he said, "I don't know a lot of stuff about that, but I'm really, really willing to learn more." So that's how I took the job. It was only because someone saw my videos on YouTube that I was coding about J3GS. Okay, and later, after 100 days of code, maybe have realized that I'm talking about other challenges as well, not only 100 days of code. So let's check a little bit what challenges I did. As I said, 100 days of code, JavaScript 30, daily CSS images, and 301 days of code. If you take a look on the first date, which is like the 100 days of code, like right here, it's just one day before 2017. So it was like New Year's Eve. And I guess that everyone on New Year's Eve, like they're outside, they're partying. I mean, not this year due to COVID, but other years, like they were outside partying. No, I was at home and I was thinking about my future. And also, if you take a look on the fourth date right here, it's sorry, on the third day right here, it's on the Valentine's Day. I guess I didn't have anything better to do, and I was coding again. Anyway, let's keep moving and stop embarrassing ourselves. I kept doing more and more and more and more challenges, and can do it. And I really wanted to improve myself. That was my goal. I wanted to be good at what I'm doing. So that's why back then and still now, like I'm reading, I'm studying, I'm coding, and I'm trying to do the best that I can because I want to be good at it, and I always want to learn and learn and learn. Now, did I gain something from this challenge? Obviously, yes. I gained so many things. Like I learned to be more optimistic and grateful for the people that I have around me. I learned to be better at concentrating faster. I learned to be better at time management. I also met a lot of interesting people, some of them offline, some of them online. Like as I said, the dev community is really big, and thank God we have internet and we can meet on and we can online meet a lot of people. And I also learned to believe more in myself and in my powers. But I also traveled a lot due to work, and except of coding, also traveling is like my second passion. So I could combine those two things, which was amazing. I'm not going to get into a lot of details about traveling and coding, but if anyone is interested in learning more, feel free to send me an email or catch up with me on social media. Would I recommend signing up for a challenge like this? And the short answer is yes. If you want to improve, if you want to get better, if you want to I don't know, to meet more people, if you want to find a job, if you want to build a portfolio, then of course do get part in a challenge like this. It doesn't have to be 100 days of code. You don't have maybe to go and use Twitter. Like these days I see a lot of people that are using Instagram. Just do it and start doing it now. If you don't believe in yourself, no one else will. Okay. And now let's change um, parts. We will continue with the second part out of the three. And this time we will talk about tips and techniques of habit formation and why this is important. Because coding and being in this mindset really has to do with habits, either you realize it or not. I will start with a quote that I really like, and it says, I'm not telling you it's going to be easy, I'm telling you it's going to be worth it. I'm not telling you that coding is easy, finding a job is easy. I'm not telling you that like being a student it's easy. No, but what I'm telling you is that it's going to be worth it. And all of your time and effort and all of those days that you're in home and you're not getting out and all of those days that you say no, I'm not going to the cinemas, I'm not going to watch that movie because I have to finish that project, all of these counts and you will see it. Let's start digging into habits. How to form habits. So the first thing that you have to know is actually that everyone experience resistance. And when you try to form a habit, like let's say a good habit, when you try, for example, to eat healthy and not sweets and candies, you will feel the resistance. You will feel that a cookie is there, or a chocolate is there, or a nice, I don't know, candy is in the fridge, and you will want to eat it. So know that resistance is always there and it will always get you. And if you understand that, then you can move on. Some things that they can help you when you try to form a habit is setting limits. Let's talk a little bit about that. The first thing that you can do is to not spray your efforts around, which means be more focused at one thing at a time. A lot of people believe that multitasking is like uh, super helpful and super good, but no, researchers actually show that multitasking can slow you down a lot because your mind needs some time to change tasks. So don't multitask. And like a small thing here is that actually researchers show that women are a little bit better than men in multitasking, but again, we are not that good. So, as I said, focus on one thing at a time and try for consistency over volume. Consistency means that, for example, you have to build a website, and the first thing that you will do is to do the register page, let's say. So, don't leave it for the weekend. Don't say, oh, yes, but on the weekend I will have some free time. No, each day, maybe even for 1 hour, maybe even for 30 minutes, just try to code something. Code something every day, just a little bit, and don't let everything just for the weekend. It's better to have just a little free time rather than too much. Because again, when you have like too much time, you will say, okay, I'm going to do that later and I'm going to do that later and eventually you don't do it. So start doing things now, start slowly, and always have a to do list in front of you. We will talk about that also in a bit, and crossing off your things. It will help you. Next thing that I guess, again, it will help you, or at least it helped me, is tracking your progress visually. And this can be done in a lot of ways. For example, this is a photo of my GitHub account how it was looking while I was doing the challenge of 100 days of code. And your mind, like, is a playful thing. It will think of trying not to break the chain. So for example, here when you see all those green little titles, you don't want to break that chain. Also, something really important is keeping a log, a calendar, a to-do list, whatever, and whatever like suits you best. You don't have to use a fancy paid app. Maybe just simple pen and paper will do the work for you. But always do write stuff down. And I know that maybe you have already read about these things that they can help you, like keeping a to-do list or being specific with your goals, but sometimes you only read about these things. Have you actually tried to implement those things? I know for myself that I was seeing other people talking about keeping a to-do list and stuff like that, and I was like, okay, I know in my mind what I want to do, why should I write it down? But then I said, okay, let me write it actually down. And I started writing down everything that I wanted to do for the day, for the week, my long term goals. I tried to do like little things that I could forget them. And I saw that my productivity actually went up because I had everything in place and I could manage my time better. And I don't know, I was feeling very proud of myself when I was seeing that I actually did something. So, really, if you don't already do that, try doing it. It will help you. Now, let's talk about something else, which again is quite important. The first thing is staying away from toxic environment. Like, if you don't want something, don't keep it near you. If you don't want, for example, to eat candies and sweets, like, don't have them near you. If you don't want to get distracted, don't keep your phone near you. Like, have your phone on silent mode or on airplane mode. Tell your parents or your friends or your colleagues that right now you're doing something important, then they cannot interrupt you. Like, have a specific time frame, time slot only for yourself, and don't let others interrupt you. And in that time slot, try to be as productive as possible. Being productive and stay concentrated isn't something easy, and it takes time and it takes practice. Try to do it. The other thing that you can do is to make the unwanted behavior difficult to be performed. What we mean by that is, like, try to have the easy things near you. If you want to code, for example, like, have your editor ready, have your passwords like ready, or like know them by heart, and again, like, block the notifications and other stuff that you know that they will distract you. Start doing these small things to make your life easier. Now, every time that we have the habit, there are actually three things that are always are being done. It's an infinitive loop. And the first one is the trigger. The trigger is the cue, something that it will like push you and you will start doing something. The second step is the routine, which is the actual habit, like how you do something. And the last step is the reward, when you're feeling proud of yourself that you accomplished something. And the reward can be something either physically or like mentally. I like, for example, when I do stuff to take a break or to go for a short walk. But for other people, maybe it can be like buying a new laptop, buying new shoes. It really depends on you. And something that works for me maybe doesn't work for you, and the opposite. Some other things that can help you is the bright line rules. This is like getting from something general to something more specific. So, as we said earlier, let's say that you want to build a website. Try to be very specific with what exactly do you want to build in that website. Let's say that you want to build the register website, the register form. Say, I will have this and this and this field, and I will do those things today, and tomorrow I will work with UI design, and the next day I will work with the back end and stuff like that. Be very specific, and every time try to subtask everything. The more you define what you want, the easier it's going to be for you to achieve it. So always a big goal, try to subtask it, and you will see that you achieve those little things. The other thing is the keystone habit. So when it's something easy or when it's something that it gives you pleasure, why not keep doing it? When you see that something has like positive effects, why not keep doing it, right? For example, if you see that you're losing weight, why not like keep doing that? I mean, if your goal is to lose weight, right? If you see that coding every day has like some benefit for you and you are improving as a developer, why not keep doing it? But now I know what you will say. You will say that you want to code, you want to learn, you want to do this and this and this, but you don't have time. Guess what, my friends? We all have 24 hours. The way that we are using these hours, it's different, but we all have 24 hours in a day. Just keep that in mind. And now let's check some tips. I'm one of those people that I want to do so many things in a day. Okay, I always want to do something, and I always like my to do list is full of things. Be ruthless with what exactly do you want to build and what you want to do. For example, you can't learn everything in a day, so be very specific what you want to learn now, what will help you now, and start doing that thing now. And then when you achieve that goal, you can continue to the next one, but please know that you cannot do everything. The other thing is change only one or two things at a time. And this is why like New Year's resolution never work, because we write a lot of stuff in a paper and we say, I'm going to change this and this and this and that. These things are like too many. We cannot change so many things at a time. So again, like be very specific with one or two goals. And if you achieve those goals, then you can continue. Also like make it so small that you cannot say no. Make that habit and that thing so small that you will always do it. For example, I had that issue with the dishes. I hate doing the dishes. Yeah, I know, silly, but I hate doing the dishes. So I said like every night I will do them, like maybe for just 10 minutes, but I will do the dishes. And it helped me a lot because now I have dishes. Okay. Start from something and think not only the best case scenario but also like the worst case scenario. So what will happen if you cannot do something, if you cannot achieve something? And I know that this trick will not work for everyone, but I think that there are some people that they will think about that, like what will happen if I don't achieve that, what will happen if I don't learn that, and like try to think about all of those things, and again you will see the difference. And the last thing here is have a minimum standard and you can always do more. For example, if you want to work out more, say that I will work out for 15 minutes every day, and I'm pretty sure that you can find 15 minutes in a day. And if you see that you like that, and if you see like all those good results that we discussed earlier, then you can always keep doing it more and more. Some other things that they can also help you achieving your goals is like doing two opposite things at the same time. This is like the yin yang principle. For example, if you want to learn code, maybe don't go for two JavaScript frameworks at the same time, but try to learn like two different things, maybe JavaScript and Java, or maybe learn maths and JavaScript, or learn French and HTML. Like just do two opposite things at the time. And something else, it's not a tip, but it's something that you could have like in mind, something that it could help you when you're studying or when you're working, is the Pomodoro technique. It's something that I actually use it daily because, as I said, I'm also a master's student. I'm studying for my master's in UX, so I study a lot, and what I follow is the Pomodoro's technique. In this technique, you're studying for 30-35 minutes, and maybe even like 25 minutes, and then you take a short break for 5 minutes, and you repeat this cycle as many times as you can. And that's how you stay concentrated for a small amount of time, but fully concentrated, and you also take a break. The last thing, which again is not a tip, but it's something that you could have in your mind, is the Pareto's principle. And what this principle says is that 80% of your output is coming from 20% of your input. This can really help you on having a clear focus on the things that you want to build. You can be like really specific and see what works and what's not working, and make some small modifications to make your output even better. Okay, I think that I've already mentioned that, which is consistency over quantity, but it's something really important. That's why I also have it here. One of my favorite expressions, one of my favorite quotes says that part of courage is simply consistency. Again, as I said earlier, if you see that something is working, like, why not keep doing it? You can only see great results with it. But also, let's talk about three tips that I don't see very often, but they can be really helpful. One of those tips is keeping a not to do list. And what I mean by a not to do list is a list that you write the stuff that you shouldn't do. This can be, I will not watch Netflix for more than 2 hours in a day. I will not eat more than one ice cream in a day. I will not stay in the same chair for more than 2 hours in a day, because sometimes we forget to take breaks. Like, keep that not to do list and actually keep it always in front of you so you will never forget those things. The second tip is to analyze your day and what activities like worth or may not worth your time. And again, like, think about it. Does it worth spending so much time on playing video games or watching movies? If you think that this is something okay, keep doing it. But otherwise, just completely remove it from your life. I don't mean stop watching movies, but I mean not watching so many movies or not playing so many games. And the last thing is that if you don't have something, imitate it. I know, for example, that a lot of people are struggling in learning English. And my suggestion there would be to go to online communities and start talking with people there, because maybe your friends also don't speak English. Maybe you are in a country that not a lot of people are talking English, but you want to improve it. So you can go to online communities and pretend that your friends are also speaking English. All right, and another quote that again I really like from Steve Jobs says that great things in business are never done by one person, they are always done by a team. That's why I talk about community and accountability, and that's why I would like to encourage you to take a part in a challenge and improve yourself, because you have like that accountability. And sometimes you think that what will happen if I don't do this or if I don't do that? Someone will notice it on Twitter or on my job. So that's how community and accountability works. Okay, and we will continue with the third part. I hope that you are still with me. The third part is a small one, but personally, it's one of my favorite parts. It's about dealing with frustration, dealing with stress, dealing with other people, dealing with colleagues, and eventually dealing with yourself. Another quote: it's not the strongest of the species that survive, not the most intelligent, but the one most responsive to change. Keep that in mind, and let's start this session. Maybe you have problems at your workspace, your workplace, what you can do with that. Think about it. Is it only you? Can you talk about someone about your problem? Is it maybe your colleagues, people from HR? Maybe it's ex-colleagues and you can track them on LinkedIn. Like, try to talk with someone. And obviously, like, if you see that those problems are still there, even if you have talked about them, then leave that place. Like, your mental health is the most important thing. Also, sometimes people think that they are not like smart enough, and they think that they are not capable of doing great things. But learn also how other people started their careers. And for example, I just talked about mine. Know that coding and learning it's hard. If it was easy, like everyone would do it, but they don't. It's hard. Don't compare yourself to others, and know that when you're getting hired, you're not getting hired only because you have some coding skills, but also because you have some other things. Like maybe maybe you have humor, maybe you are good with communication, maybe your boss saw something in you that you don't even know about that. A lot of people, and usually like young people, also have a problem with learning, and they want to learn a lot of stuff and things like that. So my suggestion here would be to build projects. Don't only watch tutorials, but actually build projects. And always have like an updated portfolio, and don't afraid to ask feedback for your projects. Actually, if you're interested about feedback for front-end projects, you can also talk with me, and I have a specific part on my YouTube channel that I do reviews and I give feedback on projects. So yeah, you can also contact with me if you want something like that. The second thing is that create a sustainable plan. Make sure what you want and try to work with that every single day. And now let's go to the last part, which is dealing with yourself. Because sometimes you think that you're not smart enough, you're not capable enough, but you are. So really, like, don't judge yourself too hard. It's okay to fail, like, everyone fails, no one is perfect. And from time to time, try to take a break the rules, like, it's okay, it's not a big deal. And remember that we all stuck from time to time, because again, like, it's not easy, and sometimes you have to fail in order to learn something. Don't act like there is something wrong with you, because you are perfect as you are. And even if you're coming from a different background, even if you didn't study at the university coding and stuff like that, it's okay. You still have all the skills and you can do it. And really, really, the last thing is take care of yourself, eat healthy, exercise, try to sleep at least 8 hours, take a shower, and all of this stuff. Thank you very much for watching my session. I hope that you liked it. If you have any questions, again, like, feel free to comment, like, share to me on my social media, on my email, and even on YouTube. Thank you very much. I'm wishing you a beautiful day, and see you.
Hello everyone, good morning. Today I'm talking about micro frontends, and this is a migration story on the edge. This is the story of DAZN and how we migrated our frontend application into micro frontends. Before jumping into the story, introduction first. My name is Max. I'm a principal engineer at DAZN. I grew up and was born in Rome, in Italy. Then I moved to London almost 5 years ago. You can find me on Twitter at _MaxGallo or at maxgallo.io. What is the agenda for today? So our journey is divided into 4 steps. We will start with the context, so what we need to understand in order to move forward to all the other parts. And then we're going to see which is the problem. And from the problem, we will tackle the problem with a solution that we will finally analyze at the end of our journey. So context, problem, solution, and analysis. Let's start with the context. Context is crucial. Context is fundamental. How many times have you thought about why that person or that team took that decision? That was so stupid. I would have never done something like them. And the truth is that the only thing that they had, which is different from you, was probably a different context. So context is what gave us the opportunity on deciding which is the decision that you are going to make for a specific problems. In the architecture space, there are also architecture decision records, which help tracking down the context when a decision was made. So context is important, and we will start from learning which is the context of DAZN. DAZN is a live sports streaming service. And in the live sports world, you have to imagine that there are a lot of people around in the platform watching some VOD content, or maybe the NBA finals that were live at 3 a.m. that you didn't want to see live, that you're watching the day after. But all the non-live content for the DAZN pretty much resemble the low-end spectrum of this graph. Then suddenly is 10:30 p.m. and there is El Clásico, there is Barcelona versus Real Madrid, and boom, we've got a huge user spike that is putting a lot of pressure under our systems. So for the nature of our solution, having something that scale is fundamental, and that has to be taken obviously in the front end, in the backend world, but also in the front end. So scalability and user spikes are one of the contexts in which we will work today. Second is company growth. When I joined DAZN in 2017, the engineering department was quite small, less than 10 people. We are now between 200 and 300 between engineers composing in general the engineering department. And that led us to a growth not only in one location, but it actually in 4 locations around Europe. And the way these changes a company is quite radical, because you have to imagine that all the dynamics and all the communication are way different when you are 10 developers or 200, 300. To give you an example, with the AWS account, when I joined in 2017, we had one AWS account, and at some point we weren't remembering who the credit card connected to that account was. So we were super worried for 2 or 3 days because it was expiring, and we didn't know who the credit card was, who the credit card belonged to. Nowadays, we have an entire team dedicated to provide at least 4 different accounts to each team working on the front end, on the back end. They're all managed. There is a CLI that helps you how to logging in, logging out, managing permissions. So that's the kind of difference that we are facing, that we faced in the past few years. And one thing we push for a lot is autonomy. Autonomy is what gives a team the possibility to go to production independently and in the most efficient way possible without having to talk and discuss with other teams. Then we have live events. I grew up in Rome, in Italy, and one of the common thing that I remember from when I was a child was that even if I wasn't watching a specific football match, out there was someone else watching it, and my neighbors were streaming and celebrating and booing for all the penalties, the goals. So I was practically able to guess the results of a specific match just by hearing it. In London, that's not exactly the case, but nowadays you get notifications on your mobile phones, you get all sorts of updates from your friends. So when we are dealing with live events, we cannot really provide you a goal 5 minutes after. That's not acceptable from a customer point of view. So speed is crucial in when we deliver. And of course, not everything is about minutes. Sometimes it's about seconds, but speed is crucial and is very important for DAZN. Then we have two front-end applications. Why two? DAZN 1.0. This is an application which has been built by a third-party company at the beginning of DAZN and which was used to serve millions of customers, that is currently live, that if you are a DAZN user, you probably have used it. And this is what the company was using for the final users in all these years. At the same time, we have DAZN 2.0 on the right-hand side, which is the newer application which has been developed internally by the DAZN engineering department that is aiming to replace 1.0. So 2.0, new architecture, new thing replacing 1.0. But for the context, I want to leave you with the idea that it was a third party, one company working on the existing project that was live, and the DAZN, the engineering department internally, which was working on the newer version, on 2.0. And that is the context. So context for DAZN, for a live sports streaming company, are user spikes first, then company growth, huge company growth, live events, remembering the neighbors streaming goal, and also two front-end applications. So this is the context in which we're gonna move forward. And we are moving forward with the problem. So what is the problem exactly? The problem is that we have two front-end applications which are functionally equal. So all the functions, the functionalities available in 1.0 in this application here are reflected in 2.0. So the new application is not adding anything new yet. What is new is the architecture behind it. So DAZN 1.0 is a monolith which contains all the functionalities. DAZN 2.0 is made of micro frontends. These micro frontends are representation of a specific domain of the whole application. So the whole application has been split in these vertical micro frontends, which represent a specific domain, such as, for example, the sign in and sign up pages. So the whole authentication experience, that's one micro frontend. Then we've got the help pages, all those pages for help out customers, the live chat. This is another micro frontend. Then we've got the catalog, which is, for example, where you see all the events and where you can play them. Then we have my accounts. But you can see how all these subdomains of the whole monolith application are now split in micro frontends. They are independent, and there is only one of these micro frontend in the page per time. The good news is that by doing this, we allowed individual team to work on micro frontends individually. And one of the first benefits that this brought was the fact that allowed us to deploy these micro frontends independently. This is the probably holy trinity of AWS, which is our cloud provider that we use to provide a front-end application to our customers. And in AWS, our architecture is relatively easy, and it uses Route 53 for the DNS, CloudFront as a CDN, and then we store our micro frontends on S3. The fact that we are now using micro frontends allow us to deploy individually the different pieces. So if I'm a team working on the help pages and the live chat, and I've got a bug fix, I don't have to talk with everyone else in the company or everyone else in the front-end world to deploy my fix. I'm in charge for that. I can deploy that. I can roll back. And you can start seeing the autonomy context, how important was in this transition time. But What do I mean about transition? While doing this transition from monolith to micro frontend, we have a few challenges. One of the first one was, how do we migrate safely our users from a monolith application that had everything to something that was represented in a different way? So the same functionalities, but split in different parts. So that's a well-established concept in the backend world, in the microservices words, and that's called the Strangler pattern. This pattern helps understanding, helps defining some rules for how to migrate from a monolith to microservices, and we applied the same concept to the front end. The Strangler pattern says that there is a piece in the middle between users and the monolith, which is called proxy. Could be called differently, but the scope of this part of the architecture is the same. And this is in charge of deciding which of the requests to the monolith should instead be redirected to the new microservices, and in this case, to micro frontends. So if we reason in the context of micro frontends, let's think about help pages once again. In the moment that the team working on help pages is happy with their micro frontends, they deploy that in production and it's available here. The only thing that we have to do in the proxy, it's saying every time a user type a URL that looks like a landing page, redirect that user to 2.0. And that's what the proxy does, and that's what at the core at the Strangler pattern. And this pattern aims to remove piece by piece all the functionality of the monolith to leave it at some point completely empty of any routes. So all the connections will now go through the micro frontends. And that's the first challenge. The second challenge is we still want to avoid big bang releases. If you think about the authentication micro frontend, the one that is in charge of sign in, sign up users, that's crucial. And we cannot really deploy that worldwide, even if it's a small part of the entire front-end application. So that's again something that we borrowed from the backend world, and this is the concept of canary releases. Canary releases is a well-established concept that says that helps you redirecting part of the traffic from one specific application to another one. In our context, we are routing with a router, this time in between. Let's say 90% of the traffic still on the monolith and 10% of the traffic on the micro frontends. This granularity allows us to minimize the impact that we have on our final users. So we release to a small percentage, we see our metrics, we set up the alerts, the dashboard. If everything looks green, we increase that percentage. And we keep repeating that until we are live. So with these two methods, we saw that in reality, we are always splitting the traffic in one way or another one. In this case, we are splitting between micro frontends and monolith, and this is our architecture. So somewhere in between here, we need to be able to do that because this is our problem. This is our challenge. We don't know the solution yet, but we know for sure which are the requirements for this solution. And these are important because later on, we will come back to the requirement to check if we have a solution that fulfills all those requirements. The first requirement is auto-scaling. We already have a huge amount of things to consider when we deal with backend and APIs regarding auto-scaling. And this is not something that we want to do in the front end as well, if possible. So if our solution was dealing with the whole scaling situation by itself, that could be perfect for us. Then we've got fast. Our solution has to be fast. We cannot add 2 or 3 seconds of delay to every request because we want to split the traffic. That's hardly going to be something that you are able to justify. And then we wanted to be front-end independent. Why front-end independent? Let's go back for a second to the context. This application is being developed internally by the zone engineers with multiple teams, each of which is responsible for a different micro frontends. And this is a monolith application developed by a third-party company. So in this situation, you always have some communication overheads in the moment you have to communicate between the two companies. As much as you are collaborative, there is always a lot of going back and forth. So ideally, having a solution which is completely front-end independent, that doesn't even know if this is React, Vue, or if this is something else, that would be our preferred choice. And then we would like to keep the same URL because all of this has to be transparent. One of our key metrics was that if not a single user realized what was going on, that was a successful migration. So keeping the same users is a strong requirement for us. And then we want to follow the best practices from the Strangler pattern and canary deployment because we saw how those can be helpful. Let's move to the solution. What is the solution? I want to introduce you to Lambda at Edge. Lambda at Edge are a service from AWS, which are a special case of AWS Lambda, which you may be already familiar with. AWS Lambda are a service that allows you to run a specific function without managing any infrastructure. So you only deploy your code, and AWS takes care about how to scale that, where it runs, when it runs, and also takes care of any amount of requests that you are hitting that function with. So it's going to auto scale. And also it allows you to pay only per number of functions that you use. So what is the difference exactly between a normal Lambda and a Lambda at the edge? The difference is where these Lambdas are running. The Lambda at the edge are running on the edge, so on CloudFront, on the CDN, on the content delivery network. That means that we have multiple instances of all these Lambdas across the globe, and they are actively running in the CloudFront, in the content delivery network, in the CDN. What does that mean exactly? The CDN is where we cache items. How can a Lambda, a function run where we cache the items? This is the flow of a request and a response that we're going to see starting from the left-hand side. So this is the request. The first thing that we hit is the first Lambda at Edge type that you can set up, which is the viewer request. And this is the cache layer. So this is where the items are cached. So in case the cache is not valid or it's stale, the request will go through and will hit another type of Lambda at the edge, the origin request. Then it will go to the origin, fetch whatever thing is happening, the origin providing. And then it became a response. So it will fire a Lambda at the edge origin response and then a viewer response before returning as a response. So all of this is happening in CloudFront, and this is the dotted line is where the items are cached. So of course, if the viewer request is hit, but after it, the item is found in the cache, we don't go here to the origin request, origin response, but we move straight away to viewer response here, and we go back to response in a much faster way. So in this scenario, we are seeing how Lambda at the edge can be set up as one of these four kinds. So when you create a Lambda at the edge, you actually have to specify, okay, this is a viewer request, this is an origin request, and so on and so forth. You can set up to 4 Lambda at the edge per CloudFront distribution, 1 for each type. But one of the key aspects of the Lambdas are that they have an input and an output, and they work with that input, transforming that into an output. Which are the inputs and the outputs of the Lambda at the edge? The inputs and the outputs are what we call CloudFront event, what AWS calls CloudFront events. They are a representation of a specific request in a JSON format. And you can see that here we have an input that is going to get a specific item from a specific origin, which is dazon.s3.dazon AWS. So this is a specific S3 bucket. Then we run our origin request, for example, and we transform that into something different. So this time we are not going to get it from the same S3 bucket, but this is going to a different S3 bucket. This is Dazon 2. So we transformed the S3 origin bucket from Dazon.s3 to Dazon2.s3. That subtle difference start opening our minds into where this Lambda edge can be used for. We can redirect traffic. We can say, instead of picking the items from here, you should pick it from there. And that's super powerful. Last thing I want to cover about Lambda at the edge is some challenges that you have to face while dealing with them. So the first one is the concurrent limit. There is 1,000 concurrent execution per account per region. That's quite generous. You can ask AWS to increase that limit to 5,000 if you have good reason. And so do your own math. That's quite generous limit. I recommend it for vast majority of the cases. That's more than fine. Deployment time. This used to be one of the problems in the past, where it was taking up to half an hour sometimes. Nowadays, it's always less than 10 minutes. I like to think it in the 10 minutes range, because this is what I see from our pipelines. But 10 minutes is kind of the worst case scenario. So we are more around 5, 6, 7. So that's the time that it takes to deploy the function into all the edge locations. So again, we'll come back to it at the end, but think about that in case you have to very time constraint that you want to take into account. And then we got metrics and alarms and Lambda logs that are all spread across AWS region. So anytime you want to find a specific log from a Lambda, you need to know where the request originated from, and you will find a log in the closest region where those functions did run. So Lambda at the edge is convenient. They run much closer to our final users, but the logs are scattered across 11 AWS regions. And that's true also for metrics and alarm. AWS did quite a nice job there, started to centralize a little bit more with dashboards, and with logs, there are suggestions on how to do logs aggregation with Kinesis and Firehorse, but it's still something that you have to do it manually. It doesn't come for free. And that was the last bit for the solution. So we saw the context, we saw the problem, we saw a potential solution. Now let's face the reality. Is that solution good for us? I want to start with costs. We didn't mention cost in at the beginning, but I feel that is an important thing that a lot of people wants to know in advance before committing to a specific technology, and you have to do that in advance. So this is our Lambda running in Frankfurt, and we have an average of 2 milliseconds, so it's quite fast. The number of requests in December, January, and February last year went from 300 million to 400 million, and the cost was between $500 and $750. That's calculated per number of requests and gigabyte per second. Overall, my suggestion is that they are cheap. Compared to other services, they are quite a cheap way of doing these kind of things. So I wouldn't be too much worried about cost. But then let's find out if that suits us well in the context of all the requirements that we had before. The first thing that we see from the diagram here is that it starts already with the right thing, because it fits quite nicely in our Holy Trinity front-end static setup, because Route 53 is already there, CloudFront was already there. The only thing that we did is add a specific function, anything. So autoscaling comes for free. We saw the lambdas are entirely managed by AWS, so you don't have to worry about that. There are limits. Of course, if you're doing something very, very silly, you may hit those limits, or you have a huge amount of requests. But for normal use cases, even the zone use cases, autoscaling for AWS Lambda functions at edge is fine. Then we have fast. We saw the average 2 milliseconds. That's fast to me. And then front-end independent. This is completely different, and this could be developed even by another team if you want to. And you don't have to rely on the fact that this is written in React or in Vue or in Svelte or in other things. You just write the lambda.js in whatever language you prefer. In our case, we prefer JavaScript, so it's JavaScript everywhere. That was quite convenient. So you can see what's going on. If you're a front-end dev working on a specific micro front-end, you can see how the Lambda works. And that's always powerful to have this kind of transparency. And then same URL. Again, that's coming for free. www.dazon.com/home didn't change because this was already part of our architecture, so thumbs up. And then we got strangle pattern and canary deployment. We have a rough idea between events and outputs, inputs and outputs of the Lambda with CloudFront events that this is possible. But exactly how we're going to do this, let's see it now. So canary deployment and strangle pattern are both, or I want to consider both, as two different configuration from the same redirection logic. So at the core, in the lambda.js, there is the redirection logic that is capable of redirecting requests from one place to another one. This logic can be driven by either canary deployment approach, when you say, Italy is all good, let's go 100%. Germany, we still want to make sure that we are doing fine, let's keep it at 50. And on the right-hand side, we have the strangler pattern when we work more at domain level. So are all the sign in and sign up pages ready to go? Yes, let's enable that. Let's route the traffic there. Are the help pages ready? Yes. Is catalog ready? Not yet. Let's keep the redirection to 1.0 to the monolith up and running until the team responsible for that is ready. Again, autonomy and independence. So we're going to see how to work with the canary deployment, but the strangler pattern follows the very similar concept. My question right now is, where do I store the configuration? And we basically have two options. The first option is here on the left-hand side, is to fit the configuration, to put the configuration inside the Lambda itself. This means that if you want to change the configuration, you have to redeploy the Lambda. And nowadays it takes less than 10 minutes, so it's probably okay-ish. Back then, it used to take up to 30 minutes, so that was much more risky. Considering if you want to do a quick rollback during a live event, you cannot wait 30 minutes. And so we decided for a slightly different approach, which is to put the configuration externally from the Lambda. So the Lambda is deployed with the normal flows, and every time the Lambda have to decide how to route traffic, it will fetch the configuration. Where is the Lambda fetching the configuration from? And how can we keep the 2 milliseconds? Because that 2 milliseconds average that we saw before was comprehensive on all of this. So this is our architecture again, and we see now that from CloudFront, from this CloudFront and this Lambda at the edge, we are performing a request to static files to keep things easy, where we store information about the canary deployment, like Italy 100%, Germany, Canada, and so on and so forth. The first question is why there is another CloudFront in front of this S3. The answer is that CloudFront doesn't allow lambda.js to request to the same CloudFront to avoid any kind of loops. So this CloudFront is not allowed to perform any request on itself. So it has to be another one. But then the second question is, why a CloudFront? Why do we need a CDN in front of S3? This is just a static files. Can I just point to S3 directly? Yes, you can, but you have a problem, and you have to remember where these functions are running. these functions are running globally. And that means that they could run in Japan, they could run in Germany, they could run in Alaska, or they could run all around the globe. So as much as S3 is this magical thing when we can store everything, that's pretty much a physical server somewhere in the world. So you have to take into account that if you were using just S3, the round trip from here could be quite nice if you're going from Germany to Germany, but could be a nightmare if you're going from Japan to Germany. So putting another CloudFront, make sure that we are caching the items on the edge in CloudFront. So the request is going from CloudFront to CloudFront for the vast majority of the time. And with that trick, we are able to keep the average, for example, in Europe, to 2 milliseconds, which is quite good. Last thing, when you redirect traffic, that you should remember is always to bear in mind that the session has to be sticky. So whatever you present to your user as one of the choice for canary releases or following the stronger pattern, if the user turn off their computer and switch it on and access the zone.com the day after, you want to provide the same experience. So with an origin request lambda and an origin response lambda, we were capable of implementing the sticky session using cookies to prevent and to give actually user a consistent experience. What are the takeaways? So I want you to start with context, context, context every time you approach every problem, but especially in this case, and when we are talking about architecture and solutions that may be useful for you. Vertical micro frontends are a very nice and effective way to split a monolith and to individually assign teams to these micro frontends, to being able to deploy each micro frontend autonomously. So if your company is growing a lot, vertical micro frontends are definitely here to help. And after you did that, you have to migrate from the monolith to micro frontend, and working on the CDN is now possible. And we saw the example from AWS, but this is not only about AWS. This is also about Cloudflare workers. So there are different solutions that achieve similar things, but this is super powerful. And we cover routing and canary releases, but that is just the beginning. There is server-side rendering, search engine optimization, authentication, authorization, real-time. There is way, way more you can do on the edge. So we are not living anymore in a world when we deal with client-server relationship. Well, we have client, server, and CDN. So let's make use of that. Thank you very much. The slides are available at this URL, and thank you again for listening.
Hey everyone. So my name's Henry. I'm going to be giving this talk. If he's still in, I'm in. And if you didn't get the reference, we're coming to the end of this whole GameStop phenomena. I'm recording this a week after that. And it kind of just reminded me of some things I've been thinking about in the last year. So I figured that we could try to integrate that to see how that relates at all to programming. And just as a brief intro, I work on Babel, the JavaScript compiler. I've been working on it for a few years now, and it's actually, funnily enough, been almost 3 years since I left my job to do this full time. So I really appreciate all the support from various people and companies to allow me to do this full time. And yeah, this talk is going to be a little bit different. I guess non-technical in a sense. We're going to be talking about how we think about knowledge, kind of how we trust, who we trust, and how that relates to how we code. And I guess fair warning, I gave a similar talk to this last year. And I know that it seems like Dave said that he got into an existential crisis. So I guess fair warning, it might not be, I'm not going to be answering all of these questions. It's just bringing up some thoughts that I've had. And hopefully, if it sparks any ideas, happy to follow up with you. So yeah, this GameStop thing, maybe it's just a Rorschach test. Was it about making a lot of money, sending a message, or just revealing issues with our financial system? And I'll briefly go over some stuff around what happened. And there's so much you could say about this. But to me, just seeing the community and kind of the sentiment around it kind of reminded me of just our own web development community. I saw that people were trying to create models to predict where the stock would go. It kind of, to me, made me think of trying to configure your JavaScript tools, whether it's Babel even. We share different tips on how to make our code faster. They share on ideas on what stocks to invest in. We have phrases that we tell one another, like we like the stock or hold the line when things are going badly or doing well. We also have our own phrases, right? Like always bet on JavaScript. And I discovered this thing in this, I guess, the financial world called technical analysis. And it seems like it's just an opportunity for you to basically make up whatever you want. And I'm not going to deny that you could probably make money through doing this, but it's funny to see, someone on the left, they drew like a smiley face to see that that's what the stock looked like to them, or the shape of the stock makes it look like it's a gorilla or something. It's kind of like when you're looking up at the sky and you see clouds or the stars, and it makes a pattern that you recognize. And it feels like you can make the graph become whatever you want. And a lot of times, maybe when we're programming, we try to fit what the code is doing to what we think it's doing in our minds when it doesn't reflect how the code was created in the first place. And so we, I guess, start the story with Deep Value, one of the people that posted his bet on GameStop more than a year ago, and actually last year in 2019. And he presented his thoughts about this. He had a mental model of how the stock worked that wasn't necessarily related to the whole short squeeze. And I think this is sort of like maybe when you're starting off and you're making a project and you put it on GitHub and you have a lot of ideas that you want to present to people, and a lot of people are like, oh, that doesn't make sense, or we already have things that do that. And you're just, I guess you're hoping that other people will come on board with you, right? You're just posting your random open source project. And eventually, and this is before, it gets viral. And this could be before your project gets the, virality of someone at a big company deciding to use it for their open source project. But, thanks to the internet and a bunch of memes, the demand increases for the stock and the short squeeze seems like it's possible. People are buying billboards of it. And then this different narrative comes about. There's a different mental model about GameStop that's not really tied to what Deep Value initially had. And this could be different or similar to how we think about with open source. The plans that you had as the maintainer, the creator of a project, when people start using it and it becomes popular, people use it in ways you couldn't have predicted. The mental model that people have now is different. They're thinking about how do we take down the financial system, or how do we shut down a hedge fund. And it's fun. You get a lot of memes, and then stuff. It kind of gets out of control in terms of where you initially started from. And I think I learned a lot of terms throughout this time, and maybe it's similar to when you're starting off in programming, where you're like learning about all these different concepts and words that don't make sense, or the names of libraries. They talk about like SSR and dry and wet and all these different things, and you're not really sure what they mean, but it sort of makes sense, so you kind of follow along with people. And I think that's what happened with the stock. I read this article about this idea that meme stocks are a form of hyper reality, where it's beyond reality, where it doesn't have any, I guess, backing in reality itself. And so this phrase that the reality defines the model is normally how things go, but in this case, the model can define reality itself. It's like they had this example of like an apple, and then one step further away would be like apple juice, and then you have like apple flavor, and then maybe I just thought it'd be fun, maybe like Soylent, there's like it's not anything related to apples at all. It's just something that you have. And so, we're not really a stranger to this. I actually think of even our own project where, uh, you know, Jordan made a satirical essay about node modules in 2016, and he had one part where he said that Babel had a picture of Guy Fieri in it. And of course, you can't actually put a picture in your code. Um, but what happened was we took that and then we added in a ASCII version of Guy Fieri afterward. But because we did that, like I guess like maybe like an hour after the essay was posted, people reading the article later thought that this was real, and so somehow this satirical thing became reality. Um, and then finally enough, Marco made this, I guess, shirt concept for us, and then I got to meet Jordan in real life for the first time because of this whole scenario. And so it was just interesting reading the comments as, I guess, in the case of GameStop when the squeeze was winding down, every negative post became a conspiracy theory where people would say that, oh, hedge funds are paying for interns or bots to downvote or comment on things. And it might be true, but it kind of felt like, and I also personally experienced that by following this whole thing. See, it's like kind of going through the stages of grief. You start from denial until you finally accept it. I think everyone's desperately holding on for the miracle when maybe it already happened. And it's really painful to be able to see yourself or other people go through this, especially if they're suffering through this financially. It kind of reminds me of this concept of confirmation bias, where we kind of seek information that favors what we already believe in. And on the outside, the people looking into what you're thinking, it kind of seems like you're in a cult, or you're just like unable to be sober minded and understand what's going on in reality. It reminds me of a book that I started reading that I didn't finish, called When Prophecy Fails. And it talks about how a group of researchers in the 50s were studying, I guess, some sort of Christian religion where they felt like the world was ending, sort of like a 2012 sort of thing. And they had, a specific date and a specific time when it would end. And they were kind of looking into this idea of cognitive dissonance, where what happens when there's overwhelming evidence that the prediction that you had and you believed in, you spent time and you put skin in the game for, didn't come true. And they were trying to point out that a lot of times people double down. People, the way they cope is they continue to believe in the thing even though it was already disproven from an outsider's point of view. And that's probably why people kind of think of, maybe sometimes at its worst, Wall Street bets could be like the QAnon of finance. And a lot of times we can find ourselves getting caught up in this in anything. I could think of being really into a certain framework or a library and not being able to take not just criticism, but just different ideas or different opinions. And I don't think this means that you should be allowed to criticize anyone and take people on bad faith, but just saying that, like, we all have our own circles or bubbles that we're in, and sometimes it's good to kind of seek out of different opinions. And I think this is important because these metaphors on how the world works really changes our whole lives. These are metaphors that we live by based on this book. A simple example from the book is this idea that time is money. All these different ways that we use this language kind of instills in us a feeling that time is money. And especially now where you feel like if you're not doing anything with your time, then you're wasting money, you're wasting your time. And it's not okay to sit around, do nothing, or it's okay. You have to spend your time doing other gigs, or maybe if there's extra space in your house, maybe you can rent it out or something. In open source, every time you're not looking at issues, you're not being a good maintainer. If you're not doing side projects, doing open source, you're not a good programmer. That's how this kind of metaphor has affected how we think about these things. And just going back to programming, as someone that works on a compiler, it's not hard to come up with this idea that compiling is also a form of understanding. When we talk to one another, I can't parse what you're saying, stuff like that. And it makes sense because I work on this project that's a compiler. We say that it's a thing that can turn inputs into outputs. A compiler is just a program that turns source code into a target language code. And more generally, when I try to explain what I do to friends that are not in tech, I just say that it's a translator. Of course, it just translates the same language to itself, which is kind of odd. But that's what it does. And I've never taken a compilers class. I didn't even major in CS. It is kind of odd that when you're trying to learn compilers, at least back in the day, we recommend reading this book. And for some reason, it's not very inviting given that the cover is trying to face a dragon, of all things. But, you start to notice that a lot of our tools are compilers. Cursor, uglify, minifiers are also compilers. Prettier is a form of a compiler. Markdown is a language that you have to compile. JSX, that's what Babel transforms. Even regex is a language that is compiled. Tom Dale mentioned in 2017, even our frameworks are becoming compilers, and this is true given the popularity of newer frameworks like Svelte and all the older ones as well. And so you might be wondering, if you have a very specific definition of what a compiler is, you can't just say everything is a compiler. But then, this is a great example from Ryan, that given how you want to see what an input is and what an output is, almost everything can be a compiler, all the way up to the sun being a compiler, like taking in energy and outputting energy. And so something I think about is like that the way we see the world helps us see things through that lens. It becomes like kind of like glasses that we put on to see the world. And so this can be a good thing, a bad thing. It's just saying that we kind of look at something from a third person view, and over time we end up seeing things from a first person view, right? We look to it and eventually we can look from it. Similarly to confirmation bias would be selection bias. When we notice something, we start looking for it, we start seeing it more and more. When you see this picture on the right, I don't wonder what comes to mind. Maybe if you've been in programming and you've been on GitHub at all, then you might have noticed that when you go to like some bathroom or restaurant, that these green squares pop up, and then you can't help but notice it looks like the GitHub contribution graph. And this can be a good thing and a bad thing but the bad thing would be more when the measure that we're seeking kind of turns into a target where, once we know that you can exploit how search works, then you might start linking websites to one another, or that citations matter in a paper, so you try to get as many citations as possible. When we think that testing is good, we start thinking that 100% test coverage is necessary, and that's the only goal that matters. I look at my own contribution graph for the last years, and you can interpret it in so many different ways. Did I get burnt out from doing open source? Did I lose interest? Did I do a bunch of private code? Did I move off to a different platform? Did I write more PRs instead of more commits? Did I just review code? Did you lose your job? Interpretation is a huge part of the data. The data itself doesn't actually explain everything. Monica did a year in review in 2017. And I think in the positive case, it's a great way to see the history of what you've done in the past year. I think in the negative case, when we start using GitHub contribution graphs as a measure of how good someone is at programming or whether they're worth hiring, it'll be used against you. And I think Jen has a great example of this in her tweet, talking about being able to explain, give context into why you might not have any commits, maybe for various reasons, right? So in some sense, it seems like not having a GitHub at all would be better than having a GitHub contribution graph with a few commits. Kind of reminds me of this quote from Ivan Illich talking about schooling. We measure schooling in quantified forms by per year. And he's saying that sometimes it seems like it's worse to call yourself a dropout than to not to go to school at all. Although you could argue in tech that we have the opposite approach because we sometimes valorize being a dropout. But yeah, this is an example of how these measures that we use in our tools and the signals that we have can be used against us in bad ways, in the worst case. And so we fight against it. We'll create bots or programs that will fill in this contribution graph for us so that people can't use that, and they have to spend the time to figure out whether someone is worth to be hiring or to work with. And so just saying that, we can't just outsource everything to these tools and signals. In the end, someone has to do the work of the process of figuring out for real, if they're worth hiring or whatever that is. And I think that's something similar to what happened with the whole GameStop thing, where, let's try to win at their game as well. And I talk about this in the context of this essay called Programming is Theory Building. It's an essay that has been shared a lot on Hacker News and stuff like that, but I think it speaks a lot to this idea that programming isn't really about the code per se, even though that's obviously a core part of it. And if there's any point to this talk at all, I think it would be that people matter in our field. And I want to present the story about why that is. And not that you need convincing that people matter, but I think there are some ways in which we use our tools and we use technology that kind of don't really help with that. And so, we can believe that, say, an open source code is not all that matters. We say that a lot, but it's like, I don't really feel that a lot of times. And so the question that we're asking is, what is programming even about? And he points out in this essay that most people think, and the normal thing to think, it makes sense. I mean, given, open source and all these things, that it is about code. It's about producing a piece of text. And this is why we say that open source is code. And it reminds me of how we might think about reading. What is reading? Maybe reading is just memorizing a bunch of statements or remembering some facts. But if you think about it, there are a lot of times we read a book and at the end, I don't really understand, or I don't remember exactly what was in it. Or even this talk, you come away with this talk, you might feel something and you might need to go back and reference it, but you might not remember exactly what quotes were said or what statements were said. And so I want to focus on the fact that, sometimes we feel like the point of programming is to remove people entirely, that the point of technology is so that people don't have to do anything. But then if you take that to the extreme, what are you going to do if all we have is the programs in tech? And I think this is similar to this idea of wanting to outsource all of our decisions to tools that we believe can make decisions better or do them for us. So, abstraction hides information, right? It's a way of simplifying things so that we can think at higher levels. And that's how everything works. It's a good thing that we're able to have abstraction. But I think at the same time, we should remember that, say in open source, when we use and we depend on things, through NPM or whatever, it hides the fact that we rely on them, even though we are relying on them more and more each day. And in turn, I say that means that we are relying more and more on the people that maintain that code. Because once those people go away for whatever reason, the code's still going to be there and it's still going to work. But who's going to know how to fix it when it doesn't work? Yeah, who is behind this code? That question isn't asked because it doesn't have to be. And you could say that's a feature. The whole point is that you don't have to know who's maintaining your code. They can just be anonymous, pictures or people or whatever, and you don't really think about that question at all. I've only thought about that since I started doing open source as a maintainer, and then starting to care about who's talking, who's on my team, stuff like that. It's because when you're driving the car, right, you don't have to know how it works. When you're using React or some framework, you don't really have to know how it works. You only have to know how to use it. You don't know how to fix it until inevitably you find a bug. This issue of being on the consuming side versus the production side. I think that if we want to use an ecological metaphor as well, we don't understand that much the processes that lead to how all of our infrastructure works. The fact that I can go to a grocery store or order fast food and get it delivered is a great convenience, and it's amazing that we can do that in our modern day society. But like this quote is saying, distance breeds ignorance, that we don't understand how things work. And I think similarly in coding, the more that we rely on these dependencies and don't really think about who's working on them, how they're maintained, the more brittle our ecosystem is. And you could see this with the pandemic and all these other scenarios and how our infrastructure has been failing. So this matters a lot because you might wonder like, oh, all I have to do is just document more, right? Is there a way to write code in such a way that I can like remove myself? I think that's kind of hard, maybe impossible in some sense. This matters because the code that we use kind of takes on the worldview or the thoughts of the person that made it. And so Justin's talking about how if you use Rails, you kind of have the ideology of the creator, DHH, and it's kind of embedded within the framework. Even if it's not explicit, even if they weren't intending it to be that way, that's just how things work, right? You can see the author's, I guess, prints in the code or how things work in the interface. And so he points out that maybe that's why Redux can be difficult to understand if our mental model doesn't match with how it was created in the first place or the use cases for which it worked. So similarly to the whole stock market thing, you can force this the value of the stock to model it in such a way that fits what you understand, but if it doesn't fit reality, then you're going to have problems. And I think this relates a little bit to this idea that we should emphasize and find the importance of caring about our emotions when we program, even though it seems like such a abstract, objective field. One example that I liked from Omar was talking about how a lot of us, me included, dread using the debugger. And this word dread, because I'd rather have the convenience of just writing console.log because it seems easier and there's less kind of context switching to do it. And so when we design our tools, maybe we should think more about that side of not wanting to do things or wanting to do things and incentivizing people to help and make tools that kind of give them affordance to keep going. And so there is some sense that, programming or any of these things is a religious sort of phenomena. The quote that I have here is from a passage that talks about science and how a lot of times when we are moving on to the new thing, sometimes you have to believe in something before you even understand it. But then before you believe it, the people that are on the other side, it seems like they're living in a different world and they speak a different language. And this is sort of what it's like to be in a different paradigm, whether it's functional programming or objective programming, whatever it is. It's different in terms of just not being able to understand because they're using words with different definitions. They see things differently, right? And so without being on the other side, none of it will make sense from your point of view. And I think this C.S. Lewis quote speaks a lot to this, that he believes in Christianity not just because of some observable things that he finds, but that fact is the way he can see all things. It shines a light on all things, using the metaphor of the sun. And so, programs can be represented in different ways. But the output of the program, the docs of the program, the types of the program, the APIs, the interface, these are all representations, our best attempts at communicating what the program is doing. Our best attempts at communicating that to other people, to other programs, even ourselves. How many times have you looked at a program and noticed, I don't know why someone did that, and then realizing that you were the one that put it there a year ago, maybe even last week, and you don't remember. That code doesn't have the context through which you created or modified some piece of code, and then you have to do the archaeology of going through the commit and then doing a git blame, looking through the issues and the docs and all these things. And that's even for your own project, let alone someone else's project. And so these are all abstractions that can be leaky. And maybe you've heard that phrase, all non-trivial abstractions are to some degree leaky. And yeah, maybe that's kind of depressing, that this code is stuck in time. It's a piece of art, it's an artifact that doesn't change unless someone acts on it. They have to be maintained by a person, and each person has a gap in understanding, even the creator themselves. Standardized things have bugs. Working at Google, you're still going to have bugs. Open source projects all have bugs. Type systems have bugs. There's no thing that will be certain. And I'm not arguing it means that we shouldn't use any of these things. It's just saying that sometimes we use them so much and we overly rely on them and expect them to be objectively certain. And so instead, Peter now argues that programming is actually an activity. It's a dynamic thing where people, programmers, form a theory. They form a mental model. And that is the most essential part of programming. So not the program itself, but the thing that is created by the person making it. And this means that it is inextricably bound to people. And so in some sense, once the person goes away that was working on some project, they kind of take something with them that will never be recovered if they never come back to it. If you just think about working at a company or open source project and someone leaves the team, you can't help but think that they've taken something that we can't ever get back, other than talking with them, doing the whole offboarding process, maybe having to message them, a few weeks later after they've left to explain why they did something. So people are important. People are essential. We can't outsource or pretend that someone could be substituted. And I think Vitalik had a blog post about wallets, as the creator of Ethereum. But I thought this one snippet was really relevant to me, that a lot of crypto is about this idea of not trusting anyone, this idea of trustlessness. But I think I like how he's saying that for him, the goal of crypto is not to remove trust, but to allow people to choose who to trust. Because this idea that can try to get rid of people kind of defeats the purpose of what technology should be for, to empower people to be able to make choices that benefit them and their neighbor, instead of removing the human element entirely. And I think even Bruce Lee says something that I think speaks to how we think about knowledge in programming. In the very beginning of any skill that we're learning, whether it's martial arts or programming, we start off in what he's calling the primitive stage, where we don't really know anything. We're just doing things based off our intuition, which is good because it's very personal, but we're not aware of what's out there. Eventually you find like a teacher or a friend, and they help you and they teach you, in school or whatever it is, what other people have learned through tradition. But the problem there is that a lot of times we get stuck here. We get stuck in this mechanical phase, almost robotic-like, where we can only parrot a bunch of rules that other people have told us because we don't know how to apply them in the right way. It's sort of like once you learn the whole don't repeat yourself you apply that everywhere, and then someone later is like, oh, maybe you can't do that in all situations. And so that last phase of artlessness is where you have to learn to kind of embody those principles and make personal judgments on where these things make sense. And so an example with testing, eventually in the beginning, you're like, oh, you don't even know testing is a concept, whether it's even necessary at all. Eventually someone tells you, oh yeah, you should test things because it'll help you. And so then you're like, okay, I'm going to test everything. And then eventually you're like, maybe I don't need tests because I spent so much time writing the tests at all, and I know where I should add tests. And so what I'm saying here is like, a lot of times we know more than we can even say. And so there are things in what Polanyi calls tacit knowledge, things that are kind of embodied in us that need to be, I guess, made explicit. But it's sort of like, how do we actually do that? That's the problem. Random example with food, that this person is saying that when they're eating with their hands, they get something more out of it than just using their utensils. By the closer they are to the thing that they're interacting with, the more personal it is, the more they can understand it. And I think trying to apply that to our tools, Illich talks about this idea that we need tools to work with us rather than work for us. Because the more that these tools work for us, the more that we depend on them, the more that we become in some sense slaves to these tools. We rely less on ourselves and we rely less on one another. We rely more on services and products that companies give us. And so, whether it's note taking, having a second brain, or an app that tracks how much water we should drink, or a way to survey our neighborhood, we're continually outsourcing what we have done in the past ourselves or with other people in our neighborhood to these tools. And just to be clear, like, I use a lot of these things too. And not saying that we shouldn't use them, but we should think a little bit about what it's doing to us, the erosion in some sense of trust in ourselves, or other people. If these tools can help us to develop habits, then I think that's good. But if we start relying on them just for the simple fact of being able to drink water, then I think something's the issue there. Same with recommendations. I'm unable to feel like I have the right judgment to make a decision in simply something as simple as, watching a movie or buying something. Maybe it's something as simple as getting a toothbrush. Now I have to find like 20 different reviews, go on Reddit and ask people for help to find what's the best thing I could buy, rather than just being okay with what's there. Michael Secassis has this great essay about a similar idea, like what did we lose when we lost the stars? And he's talking about the idea that all these satellites are going to be up in the air and we're not going to be able to see the stars anymore. That darkness will be covered. You could say the same about silence, not being able to be silent on social media because the only way you can interact on social media is to tell someone that you're going off of social media. And it's not saying that tech is bad or anything. It's just like, how do we count the cost of what tech can, the negative effects of tech as well. Illich has this concept of the radical monopoly, where it's not a company that's a monopoly, but a whole set of services that overwhelm people that are not in it. And so he gives the example of cars and how that overwhelms the need for bikes and walking, that we create highways and cities based around the car rather than the person. And I have this example of New York's Union Square of trying to remove more of these roads and remove the need for cars so that more people can walk around and experience city life. And I think it's a great change to be able to think of this in a different way, to notice where we are not really emphasizing humans, people. And just to think differently. And I think this is a really random example, but I found out that Tech by Donald Knuth, the versioning the way he does it is that he thinks that it's better for him to not introduce new features and for the program, which has been around for 40 years, to produce the same output. So the way they version it is that every version is only patches, and they add on one more digit of pi, which is kind of amazing. And so he's saying that once he passes away, they should just change the version number to pi, because all bugs will become features. And that's very different from, say, how we do in JavaScript. We're always trying to break things and move on, move fast. It's just good to kind of see something different, even if I don't think that might be applicable to what we're doing. Yeah, maybe we should think about tech differently then. Even the Amish, that doesn't mean they forego tech entirely. What they do is think about tech within a community where they gather together and say, is this worth it? Is this helpful for our community? To question it at all. It doesn't mean they won't use it anything, but just to think about it at all instead of always moving on to the next thing. Like, people before were kind of afraid that students would start using calculators instead of manually calculating. And I think we don't need to go back to that or anything. But yeah, just what are we losing through automation in our tools? Because these tools are extensions of our bodies, right? And so they affect us. That our tools, we shape our tools and our tools shape us, even if we're not aware of it. Polanyi talks about this idea of indwelling, where we learn to indwell the things that we're learning and the things that we use, right? If you're like an athlete, right, your shoes or your instrument, if you're a musician, your keyboard, if you're a programmer, we learn to kind of embody the things that we spend time on. And so technology itself is a living thing. And it's important for us to realize that the person is a vital part of that. And I think Dan has this great article that he has this story where he talks about how this particular shrine, they actually destroy the whole temple every generation and rebuild it anew, which sounds, like a lot of work. But that's an acknowledgement that it's not enough for them to create the documentation on how to build the shrine or to have the tools to create the shrine. We need the people to know how to do it. This is true of manufacturing, right? And this is true of programming. If I put myself or someone that is not experienced in cooking into a kitchen, right, and they had all the best tools, they had the best recipes, if for me, I wouldn't be able to make a good food. And I'm sure maybe someone would be nice to be like, this was good, but I'm not the expert. I wouldn't know how to use these tools well. And an expert would know how to use even if they didn't have the right tools. It's not that different from in programming. You have your VS Code, your favorite editor, you have the power mode extension on. You have the docs available. If you don't actually understand the mental model, you won't be able to really do anything with this. And yeah, you could use Notepad if you're the expert, and you would be fine as well. And so this program has a life cycle. The life of the program is within the time period that the team that works on it or the people that use it even retain a working theory of how the program works. And you could even argue that that lifespan is really short because eventually a program becomes so big no one really understands all of it, at least in their head. And then the program death happens when people don't understand how things work anymore, right? When the model doesn't fit anymore, when that stock price doesn't match what your model was. And so this is an example of the map not being the territory, the representation not fitting reality. It's really easy to do machine learning and overfit things, right? The data points. You can make any formula that will match the data in the past, but it doesn't mean it'll match the data in the future. People create all these graphs on this GameStop stock. They have all these names like cup and handle and wedge. It looks like a triangle. Just because no one can predict what will happen. And in the same way, we rely on our linters and our tools to help us understand things, but sometimes we kind of outsource it entirely where we don't really know what's going on at all. And I think that's definitely the case for me a lot of times. And so what we need is a revival of that theory. We need people to be able to rebuild step by step what is going on. And without people, the original people, it's a lot harder. If all the maintainers left of a project, the program would still work. Battle would still run if we all left. But the problem is that once a bug inevitably comes up, who's gonna figure out how to fix it? That expertise is valuable, and I think that's a big reason why the sustainability of open source in terms of funding is so vital. That it's not just because we want to pay the people there, but it's because as a company or anyone using it, you actually would want this to happen. You would want to sustain the expertise of the original people. And so yeah, a lot of coding isn't about coding, and I found this to be the case the more and more I've been in it. And yeah, my point is just that programmers are not resources. They're people that have expertise. And similarly to the whole thing with MDN, right? I think people had a lot of goodwill in terms of wanting to volunteer and help out, but I think it kind of just forgets the fact that not anyone can just do it. Not to say that we're trying to gatekeep people from wanting to maintain or help out, but recognizing that it is worth paying for full-time people or the people that were working on it before. Yeah, tech is a living thing, and I think maybe sometimes when we're thinking about how to move forward in a project, we should think about whether that thing is a living thing or as a cat or as a toaster. And I think open source as code isn't cutting it. It's not enough to just say that that's all there is. Just like in a city, it's not just about buildings, but it's about the people that live in that city. The environment isn't just a bunch of resources, but it's resources that all of us use. And so I end with asking myself, like, how do I see the world? How is it affecting my work? Maybe it's ironic that I work on this project called Babel. Am I just working on a Tower of Babel, that I'm creating these tools that make me prideful, but in the end just end up, falling down. All right. And I think that's it. Thanks.
Hi everyone, I'm Matteo Collina, and today I'm going to talk to you about Fastify. Let's start. So, first of all, this is a very, very brief introduction. It doesn't want to be a complete thing. Please feel free to follow me on Twitter at Matteo Collina. I typically tweet a lot about Fastify and open source and Node.js and a lot of other things. So you will really, I think you will love it if you have liked this talk, essentially. Let's get into things. So first of all, Fastify, Fastify is a web framework for Node.js. It has a website, fastify.io. You can check it out. It is full of docs. If you want to contribute and improve the docs, please send PRs. Essentially, everything is open source, even the website. Hey, so let's So this goes into enlightening one of the key features of Fastify, which is, to be honest, not a technical feature. Fastify great thing is about its community. And it's the fact that Fastify is a community-owned project. In fact, it's part of the OpenJS Foundation. And it's community-based, so essentially it relies on you to make it great. How? Well, contribute back. That's the key feature of Fastify. We ask everybody that is using it to contribute back as they can. Let's look a little bit at the browser. So Fastify is one of the fastest web frameworks for Node.js. It's been downloaded quite a lot, maybe even 800,000 right now. This slide might be slightly up to date. And it has a lot of collaborators, and it has an ecosystem of 177 plugins. So what are the core values? First of all, open governance and consensus seeking. It's, as you've seen, there is a lot of people, as I said, there's a lot of people being involved in Fastify. We have a lot of collaborators, a lot of people, everybody is heard, and we try to we apply a consensus seeking approach. What does it mean? It means that whenever there is somebody that is trying to land a PR, we try to reach consensus, meaning that we ask, does anybody object to this PR landing or this decision being made? This is one of the key part of the community, so that we don't let everybody fell outside of the community. We also value a lot first-time contributors. So please contribute. We even have a page on our website. Like, you can go to fastify.io and you can see that we have a contribute page here where we can see that there's a lot of open issues those are all good first issues that people can take. So anyway, the concept is about shared ownership of the framework. So if you find a bug, we will ask, would you like to send a PR? We are not selling you anything. So if you want to participate, please participate. In fact, Fastify, all of these, it exists because Fastify was born before any code was actually committed, which is one of the greatest things. When I started thinking about doing a web framework, I decided, well, maybe I can start thinking before doing it, like, it's going to be too big. So because it's going to be too big of a work, I started thinking maybe I can ask, I need to find somebody else to work with me. And this person was Thomas Della Vedova, which was the other lead maintainer of Fastify. We started working on this together when he said, well, I'm interested in developing one, I want to learn. That's what how it happened. It started as a learning project. But then sooner, we keep attracting more contributors, and it grew in the production capable framework that it now is. It's, as I said, is a shared effort. There is maintaining a web framework is such a gargantuan effort that it's really hard to justify without funding or a company behind it. So how are we taking this approach? Well, we have crowdsourced it. We ask people using the framework to contribute fixes. So if you have a fix, please help send us PR and add unit tests. And this comes in the key part of the co-ownership culture of Fastify. It's not really present in any other web framework, to be honest, like this sense of shared ownership. This is everybody's thing. You can look at our governance, and we actually nominate other collaborators very often. We have just nominated a bunch. So, hey, more people, more awesomeness for everybody. Let's go into a little bit of the tech principles of Fastify. So first of all, one of the greatest thing is that we go for zero overhead in production. We don't want to slow things down compared to Node Core. We want a good developer experience as well. Not perfect, like developer experience is one of the key non-functional requirements for a web framework, but we also wanted the performance first. So we don't want to compromise on performance. We want the framework to work great for small or big projects alike. So you can use it for small things, you can use it for big things, they both work fine. It needs to be easy to migrate to microservices or even serverless and back. We'll talk a little bit about that later. It needs to be secure and provide built-in data validation. It needs to have a plugin system. In fact, if something could be a plugin, it likely should. Like, we tend to keep the core pretty small so that it can actually be solid and solid over time. If we brought more things in, we need to bump the major way more often than what we would like. It needs to be easily testable. It does need to monkey patch Node Core. Unfortunately, monkey patching is one of the things that happens all the time with other frameworks. And it needs to have semantic versioning and long-term support. Last but not least is follow the HTTP 1.1 spec. So fast, it's in the name, right? How fast is Fastify? Well, this was taken from the Fastify core benchmark, which is Not super reliable, to be honest, mainly because they run on a GitHub Actions. We typically used to run them in a dedicated hardware, but no time this time, no time right now. So here they are. They are pretty neat, and I really like them. So you can read what you want here. It's the situation is as it sounds. It's also loved by developers. Like Fastify, a lot of the developers really like working with Fastify, and this came from the state of JavaScript. Again, this does not mean much. It's a survey that is probably skewed a little bit, but again, it's a good data. It also supports. I also have another project that provides GraphQL support, which is great and it's really fast. So you might want to check that out. Anyway, going back to it, I am having Fastify. It has 43 core plugins and 124 community plugins. It's a lot of plugins. Okay, Fastify is a community. It has a lot of things that you can do that the Fastify framework does on its own, but even more that it does broadly. It's great. So I just wanted to, before going into a little bit of the technical details, I just want to talk about the target architecture of a Fastify application. Usually, when you're talking about a mean or a MERN application, you have a typically 3-layer system where there is a model, view, and a controller that orchestrate everything. So the model talks to the database, of course. Now, this is what is called a typical monolithic architecture. So it's very hard to evolve this over time. You have a model, you put all your models together, you put all your controllers together, you put all your views together. You don't have much choice in which you divide your application. Now you can easily reach applications with 2,000 models very easily. And so it's one of the key things here. Now, one of the biggest thing of Fastify is that we wanted to solve is to use a very different structure. So we wanted to have still provide build a framework that enables you to write code in using by features. So instead of having dividing your code in model, view, and controllers, just divide it in by features so that it's actually way simpler for people to discuss things. Now, what you can do is you can say, for example, I have a user and all the things in the user go into the user module. Then I have a lot of things in the cart. The cart goes into its own module. And you can grow things organically in a linear fashion, right? In going horizontally, so that it does not grow vertically. And so it doesn't grow into, each one of those can maintain complexity very quickly, can help you maintain complexity. This is a great feature from my point of view, and one of the key things that I really like the most. Now, the target, it's actually moving into microservices. And we wanted to build I really wanted to build a framework that can help you move from this thing, from a simple system, from a monolith to a microservice system. An MVC pattern does not really get you this far. So think about it. Now, let's go to it in depth. The typical internals of Fastify are using several components as well as other stuff. So key components, key libraries that we are using is Find My Way, which is the router. It's AJV, which is the validator. We'll see that in a moment in an option. JSON Stringify, again, used for serializing our responses. It uses Avio, which is one of the key things that I've wrote, which is actually the plugin system itself. Pino, which is the logger. Again, we'll cover all of this. Then there is a key part of functionality it is Fastify own, which is how it manages plugin, how it does hooks, and how decorator works, which is what we're going through right now. So it is the clear description of the plugin system of Fastify. Fastify enable you a faster usability via the use of plugins. Essentially, in Fastify, everything can be wrapped inside a plugin. You can have routes, you can have, and in a plugin, you can have routes, you can have hooks, you can have decorators. A plugin creates a new context, a new encapsulated context. So everything you define there will not pollute other contexts. These enable us to keep some sanity in how we reuse our code and our software. So if you call decorate, if you add a new property on inside a plugin, you can that will only be only the descendants from that plugin will see that new property. So you can add it to the request, the reply object, or even the server itself, but only the descendants will actually see that property. How do we use it? How can we break the encapsulation? We can use an utility called Fastify plugin, or maybe just attach a symbol on the function. And that will enable you to publish that thing up. More importantly, this applies also for hooks. So for example, we can, Fastify does not have the concept of middlewares, even though we support middlewares. I'll talk that later. We support lifecycle hooks. So essentially, you can say, for example, I want to execute a request when it receives the system after we have done routing. This is the onRequest hook. Inside the onRequest hook, I can perform, for example, authentication. This is a really good place for authentication. However, I can use that system to apply that authentication only for a certain path of routes. Now, I can put all those routes in a plugin on a plugin and add a hook at that plugin level. Hey, that's it. And those will be secure. That hook will not be used outside. This is different compared to a middleware-based approach, where you will need to use some very complex regex or something like that to only apply authentication on certain paths and have the middleware execute every single time. We also recommend a kind of a project structure, which is having a file called app.js, having a plugins folder for your reusable things, and then have a routes folder for the rest. So this is what we recommend. You can use whatever you want, really. Note that with all this encapsulation stuff and lifecycle, you can actually get very close to the target architecture I was speaking about. You see that you can move from structuring your application by feature to actually having the multiple plugins. Each one of them maps to a feature in your app. So seems pretty cool, right? It would work. Now, what's a cool thing is that we can also switch to microservices very quickly just by decomposing them. Each plugin, in fact, can be taken and moved out. So it's way simpler that way to move from a monolith to a microservices architecture. We can also use some of the flexibility to use to embed an Express app. In fact, you can take any Express app and actually run it on top of Fastify. It will just work. In Fastify, logging is a first-class citizen. You can see that Pinot is one of the fastest loggers for Node.js. It logs as JSON. This is a good talk about Pinot from 2016. But I love this talk. Is my David McClemens and myself, we both created Pinot together, where we did this. And Pinot is a fast logger for Node.js with minimal features. It's been downloaded quite a lot, and it has a few collaborators. How do you use Pinot? Well, you instantiate Pinot, and then you log through it. Very simple. You can also create child loggers, which is one of the critical features that we use in Fastify to provide the best of both worlds, essentially. Let's go and talk about serialization. Serialization is one of the features that I really like the most, because it enables us to create JSON way faster than JSON stringify. How? By specifying the format of that JSON. A lot of the cost that we pay for serializing things into JSON, it's because it's free format, right? By providing a schema, we can actually create a very specialized function that can actually render it blazing fast, which is what fast JSON stringify does. And if you don't really like to write a complex JSON schema, you can even use a library called Fluent JSON Schema that enables you to write it super simple with a Fluent API. It also has TypeScript support, so if you have auto-completion in your editor, you can actually auto-complete it and create things very quickly. As for validation, we use AJV. With AJV, you can define define what type of schema, a body or the query string or the headers is being passed through your application. It's pretty neat. I love it. And finally, the testing, which is another bit that I think it needs to be first-class concern, is that Fastify support a .inject method, which enable you to call any of the routes. These can be used for some integrations, but as well as for testing. I use it all the time. I told you about microservices, right? Well, there is also the fact of lambdas. Lambdas are great. And how do we use it? Well, there is a nice utility that uses Fastify inject that we talked about a second ago, and it enables you to actually write a single Lambda application, take any Fastify app and deploy it as a Lambda. So you take it and you can just wrap it, and it will just magically works. So it's just so great. Of course, Fastify also support a .close method if you want to gracefully shut down the process. So, okay, it's I promise you a live coding performance. So let's get started. So you can actually write a server, right? And if you write a server, you can say import Fastify from Fastify. So we can actually, here we go. Oh, I need to actually, slides, here you go. So we can actually Fastify from Fastify. So after this, we can create our app by doing, so call app.listen 3000. And we want to do this because we want to listen to all ports. So if I do node server, and then I can curl localhost 3000, route get not found. Cool, okay. So it seems that we are making progress. So we need to define a route. So we can do app.get, and here we go. And then we can do async function request reply, and then return hello world. Cool, okay. So if I do this way, yay, now it's rendering. Nice. How? Well, I also maybe want to log something, so I can do logger true. Oh, it's logging, and then I can do curl. Cool. Okay, so if I want, I can also do npm I pretty. I'm downloading a module and installing it. Hey, happy days. It's actually pretty neat. So I have pretty, so now I can do node server npx pretty. And now I can have prettier logs. So prettier logs for me. Cool. So this is a very simple thing. However, I can't do much with it. Okay. So the first thing that you would do is that we might want to split this into its own routes, into its own route, right? So what I'm going to do is I'm going to edit to create a folder, routes, and then edit, copy this, and then said edit routes hello.js. And now I need to do a few things. So I need to say export default async function. I can do things, function app. And here we go. Okay. So I'm running it. And it's still working. Well, it's still working because I haven't changed much. So I also need to change my server. So on my server, instead of doing this, I can do app.register import. Well, what I'm putting in here. So I need to put something. First of all, I need to import join from a nice module that I wrote called DSM. So npm I DSM. And here we go. Oh, I messed up. So import join import meta URL, which is the URL of the current file, and then I want to do routes and then hello. Okay, so now I'm running it. Oh, I missed one. Great. I'm running it. Oh, what I've done. Oh, cannot find. Where does it say this? Routes. Hello. Okay, so it's there. Yes. So when you're dealing with ESM, you always need to remember to put in your extension. Always put in your extension. So node server. Oh, so here we go. And then I can curl. And it's now working again. Okay, so we have, in fact, you see we have created our first plugin, which is nice, right? So now if I wanted to keep, like this is not really working and we are a little bit running out of time. So if you wanted to write a unit test, what I would do here. So first of all, I would split this into two files. And one is called app.js and it just does this export default async function, and what I would do is I would take those two things and I would migrate them here. Okay, in this way I can, this is a factory that will help me create as many Fastify instances as I like, so I can create one for each one of my unit tests, for example. Now, what I would do in here is that I would do, and here I need to return. Here we go. So what I would do in here is that I would import build from app. So here we go, and then do const app await build. I don't even remember if, oh, yes, app.js. I keep stumbling. Here we go. Whoa, it's working. How? Well, because there is top level await, right? It's a thing. So I can, so in server, we have, we can call await from build, and then we call listen. And in build, we are just returning as a factory. Now we'll split those two things. So in a unit test, you could actually load things manually. Now you can we can take this one tiny step forward in this. So we need to first of all install another plugin called Autoload. And Autoload is a plugin that enables you to create a new to load a folder from your from disk, to load all the files in a folder from disk as plugins. So what we are doing here is that import Autoload from Fastify Autoload. Cool. So what we are doing now is that we are registering Autoload and then telling them to load this folder. Let's see if this works. Oh, what did I miss? This is too much. Oh. Oh, yes, of course, because we are loading a file, it's not a folder. So here we go. Oh, it seems working. It's loading. Let's see if our route is there. Oh, it's there. Okay. So as you've seen, we have created we have created a structure where I have our server file, which is my entry point, which is using top level await to call import build. And then I have created another file which is this is a constructor and the builder for my instance. If I'm going to write unit tests, I am going to use this file to instead of the server one. The server one is only for prod, essentially, or for development. So it's only when we are actually deploying things. I'm using Fastify autoload to load all my modules that are defined in my routes folder. Pretty neat. You can also set prefixes and things like that, so you can just say, "Oh, I just want to load all these files in a single module as a thing." So anyway, I just thumbs up. So thank you for watching, and it's been such a big pleasure. My Twitter account is @Matecolina. Please ping me and reach me as soon as you have a question for Fastify, and I will be very happy. My DMs are open, by the way, so if you want, please. And I would just say thank you very much. Bye. Bye.
Hello, everybody. My name is Sean. I'm the co-founder and CEO of Magic. Today, let's dive into the topic of authentication, the missing Lego piece in Jamstack. I was first introduced to Jamstack via this tweet from Tom 2 years ago, that within 5 years, developers will be building large-scale, fully featured web applications with Jamstack. Fast forward 2 years, there has been a proliferation of Jamstack projects and companies, and we've come a long way in terms of enabling a variety of amazing functionalities on top of the Jamstack, including more options, application framework like Next.js and Redwood.js, deployment platforms like Vercel, databases like FaunaDB, and headless CMS like Strapi, as well as many other third-party integrations in the area of e-commerce and communications. We're well on our way to enable the future where Jamstack is at the core of the next generation of fully featured, robust, and large-scale web applications, with a significant reduction in the amount of code developers have to write to enable it. Besides more functionality, there has also been a proliferation of different ways to manage user authentication from various projects, as it is required to provide data and services to applications and users. This may actually complicate things, though, as they're not necessarily designed with the application frameworks in mind, causing fragmentation and making it very tedious for developers to learn and integrate many of them in their applications. Many developers would have to roll their own authentication solution, which can be extremely expensive and challenging to maintain, scale, and keeping it secure from cyber threats and compliant with various regulations as their application's user base grow. Here's where Magic comes in to fill the missing piece, providing standardized user authentication that is tightly integrated with application frameworks like Next.js and Redwood.js, which can drastically simplify the overhead of implementing user authentication and integration across different login providers and services. We at Magic are committed to enabling a passwordless future because passwords suck. No one wants to memorize yet another password when our heads are already packed with them. Passwords are a huge attack vector for security breaches precisely because it puts the burden of choosing a unique and secure password on the user who just can't be bothered with it. We end up having one password for all the or in school, one for social media, and one for all the miscellaneous one-off services we don't care too much about. The result is that a whopping 59% of people reuse their passwords across services, which means a data breach anywhere quickly becomes a liability for the entire web. Over 93% of all breach records happened in the last 8 years alone, and it's only speeding up. The era of password-based security is over. It's super stressful too for the end user, because every failed login attempt is a step closer to a locked up account. The stakes of figuring out which password we use are so high that frequently we admit defeat before even getting to the third try. Existing solutions on the market are too contrived and unwieldy. After all, a password manager is just a notepad where you use one password to guard your other passwords. In the middle of one login experience, users are asked to visit another app, log in there, locate the credentials associated with the service they're trying to use before they can even proceed. Between choosing, recalling, forgetting, and ultimately resetting passwords, logging in has quickly become the Beckett play of the internet. Supporting passwords is a nightmare for developers too. They need to be encrypted, salted, hashed properly before they can even be stored. Not to mention the upkeep of maintaining account reset features and all the business resources allotted to the event of a security breach. Every one of which continues to erode the already tenuously kept trust on the internet. The business impact of password-related incidents are also immense, where 48% of customers never come back after a major breach. Companies suffer from overwhelming support tickets where 50% of them are password resets and login issues, costing an average of $7 per ticket. Lastly, lost revenue opportunities, where 1 out of 3 shopping carts are abandoned due to forgotten passwords. Going passwordless solves all the problems above and is socially responsible by stopping password-related breach at its source. Instead of contriving password strength validators, maintaining reset flows, and dreading PR nightmares of security breaches, websites should just log users in with a one-time link sent to their inbox. Let's face it, for better or worse, the entire security model of the web is already based on email. We already verify accounts with emails. Just imagine checking your inbox instead of struggling failing to recall a password. The result is an internet that feels just a little cleaner, without all the fussing over secret phrases that can compromise account at moment's notice. And this is what we do at Magic. We're building a simple plug-and-play passwordless auth that is radically better. With just a few lines of code, you can support a variety of login methods, such as magic links, social, SAML, and even WebAuthn, on top of almost every software stack, taking care of developers' use case from start to scale. We obsess over the developer experience. Logging users in should feel simple and pristine, as if you had wrote the authentication yourself. No need to fiddle with unwieldy dashboard configurations until you're ready to ship. Very little setup is involved in getting started on the front end. And we also offer a robust admin SDK that makes integrating your backend servers super painless. To ensure reliable email delivery, we strive constantly to maintain the best sender reputation and deliverability of everything sent. We also select multiple mail service providers based on delivery performance of transactional emails. Our redundancy failover mechanism ensures that service interruptions to mail providers don't keep links from being delivered on time. Magic handles your authentication overhead, so you can focus on what matters most to your business. To further secure our passwordless login, we have also developed an anomaly detection system which blocks malicious logins based on usage patterns. On top of that, we've acquired a SOC 2 compliance and service level agreements, and we'll be integrating multi-factor authentication to your app a breeze. We at Magic believe that developers should own their brand and user experience. Magic lets developers apply themes and customizations to their user authentication experience, or completely white label it. Can leverage our internationalization support to help expand their reach to users across the globe. On top of that, Magic's user interface is also built with accessibility requirements in mind, which is super important for enterprise customers. Magic aspires to be the one auth SDK that connects to everything, like the segment of auth, aggregating and simplifying the integration of multiple login providers on the client side and seamlessly connect to developers' very own backend, databases, and other third-party integrations like payments and e-commerce platforms. It's non-trivial to do this in a clean way while keeping a simple developer experience. So how does Magic do this? Before we start, let's do a quick refresher on how traditional authentication flow is implemented. It all starts with a single user setting a password. Secrets supposedly only they know. Users will be using this password to prove that they're who that they say they are to developers' applications. Users then hand the secret to developer servers, completely entrusting them to handle it properly. Normally, it's hashed and salted and gets stored in developers' databases. And every time user logs back in, the password secret is sent to the developers. User identity resides not just on users' hands, but also developers as well, which creates a risky single point of failure for high-stakes applications and the ones that are growing rapidly, making stored passwords a huge liability for data breaches. Instead of using passwords as secrets, Magic does this by abstracting user identities as public-private key pairs. When a user successfully signs up or logs in to a login provider, Magic either generates or loads a key pair onto the browser into an embedded iframe that is inaccessible to the developers in order to protect the user's private key. To further improve security and trust, these keys are generated on the user's client instead of Magic servers. So technically, users own their identity and Magic won't be able to see those secrets. The Magic SDK then uses the private key to generate an authentication token called the Decentralized Identity Token, or DID token, which implements W3C's standardized identifier standard. The DID token is then passed to the developer server side, and the public key or the user identifier can be easily derived from elliptic curve cryptography, which is abstracted away in our admin SDK. Note, neither developer or Magic will be able to see user secret. The private key, this is a cool new way to log users in called zero knowledge proofs. In addition to the security and privacy benefits, the elegant part of this solution is that passwords and third-party services only have to deal with the DID token, which is an open standard to authorize users instead of having to learn and implement every single login provider that is supported. Hence, the segment of auth and making Magic solution highly extensible. Magic believes in an internet of people, not credentials, and fights to safeguard the trust between users and internet services. This is becoming increasingly more important, especially in a world where more and more people are going online, where internet services are becoming the necessities, while user trust on the internet is eroding. Magic does not strive to be a centralized identity provider. We're not interested in becoming yet another monolithic data collection entity with tendrils around everything from your usernames, addresses, credit scores, to dating preferences. We provide the necessary infrastructure to authenticate and authorize users to applications and services, and that's it. And to date, Magic is securing millions of requests per month from trailblazing companies. And this is done by our world-class team we've assembled that build products used by millions, spanning many industries from dev tools, infrastructure, and security. And we're just getting started. We're absolutely thrilled to be part of the Jamstack ecosystem, introducing easy and affordable authentication as one of the Lego pieces. We believe with Magic authentication will help unlock more feature-rich applications built on top of the Jamstack. Developers into the ecosystem. You can learn more about Magic from our website at magic.link. Check out our documentation, as well as many awesome guides on how to use Magic with various tech stacks. And follow us on Twitter at magic_labs. Thank you very much.